Hey guys, welcome back to my channel. Today we're going to talk about the OSPF protocol. Okay, now there are different types of LSAs. Okay, I'm going to talk about let's say a few LSAs, not a lot. There are a lot of LSAs. I think there are like 8 to 9 LSAs, but we're going to talk about like the major ones, which are important ones. Okay, and remember that all the routers in the area will have the same LSDB, and now, one thing about the area concept, right? Why do we have multiple areas? What is the need of having multiple areas? First thing is, if I have another router over here, let's say I have another router, okay, over here, okay. Now let's say this is part of area 0, okay, and this is part of area 1, okay. All the route updates of area 1 will not be sent to area 0. So it reduces the number of route updates. That in turn reduces the size of the routing table. That in turn reduces, the processing power of a router to go into each database and look for an IP. And it also helps in like preventing of loops. Okay, if so, one thing about area 0 is every area should go via area 0. Okay, so area 0 is also called as your backbone area. Okay, so say if I have 10 to 15 areas, and then all these areas will be connected to area 0. Okay, this is how the areas work. Okay, now as I've told you before, there are like the different types of LSAs. So the first LSA what we're going to talk about is type 1 LSA. Okay, which is a router LSA which is created by each router, and it contains the information about the directly attached networks. So R2 will basically send, okay, now R2 is part of area 0, okay, and it's also part of area 1. So this R2 is called as ABR, okay. ABR is nothing but area border router. Okay, now R2 will send an LSA to R3 about network 11.110/24, right? Correct, because this is the interface 1, and it will send R1 about 10.112/24 network. Okay, so it will also send the information about 11.110/24 to R1, and it will also send 10.110/24 network to R3. Okay, so these are type 1 LSAs where router LSA is created by each router and contains information about the directly attached networks. Okay, type 1, that is type 1 LSA. Now type 2 LSA is basically when you want to send information about each network, and also you are going to choose a designated router. So let's say in this case I want to choose this as DR. Okay, so this link is where I am choosing DR, right? So the LSA which I'll be sending over here from R1 to R2 to choose R2 as my DR. Okay, this LSA would be a type 2 LSA. Okay, now what is type 3 LSA? Type 3 LSA is basically also called as summary LSA, where the ABR, the area border router, is basically used to send the information of the routes or the networks present in one area to the other area. So R2 will send a type 3 LSA. Okay, R2 will send a type 3 LSA about the networks present in area 0 to area 1. Makes sense? Okay, also called as summary LSA. Now generally what happens as a network engineer, right? Let's say area 0 has networks 10.1.0.0/16, it has 10.20.0/16, and like that many networks it has, contiguous networks it has. Okay, so instead of sending an update for all of these networks, right, as type 3 LSA from R2 to R3, what I can do is, what it will basically do is, it will basically create a summary of it by saying 10.0.0/8, okay, which will cover all these networks. Okay, put all these networks and mark it as just one LSA, and tell area 1 that if you want to reach any IP of which is part of this network 10.0.0/8 has to go via R2. Okay, So now basically, let's say if you had 12 networks over here, these 12 network updates are now concised into one particular network, right? So you have reduced from 12 updates to just one single update, and this one single update goes to R3 instead of sending 12 updates. So this again reduces your routing tables, memory. Okay, you don't have to do more lookups. Now also it has more information. Now R3 has, by just getting one update, it has area 1 has all the information about all the networks present in area 0. Okay, so that is type 3 LSA. Now we have type 4 LSA. Okay, type 4 LSA is used when, let's say I have another router over here. Okay, and this router is part of EIGRP or another AS. Okay, let's say I have some router which is part of another AS. Okay, now I'm getting some 50 routes from EIGRP, which is redistributed into OSPF over here. Okay, so now this would be called as ASBR. ASBR is what? Autonomous System Boundary Router. It's an interface router between two different autonomous systems. Okay, so now R2, which is part of area 1, and R3, which is part of area 1, should know how to reach this ASBR. Correct? So this information is relayed by type 4 LSA. Okay, type 4 LSA will give information about how to reach the ASBR. Okay, now this will be sent from R4 to R1, and it will be sent from R1 to R2 and R2 to R3. Okay, now type 5 LSA is basically giving information about all the routes that have been redistributed by the OSPF from EIGRP. So let's say I have some 50 networks over here which I can reach through R4. Okay, now that information will be given by type 5 LSA. Okay, now this type 5 LSA is basically called as AS external LSA. Okay, so AS external LSA is created by the ASBR. It is created by the ASBR, okay, to advertise networks in different AS. So type 5 LSA will be sent to R1, R2, R3. Okay, so that it knows, okay, so these are the networks which are hosted behind this AS into another AS, and these are the networks you can reach via this ASBR, and this ASBR information is given by type 4 LSA. So these are the different types of LSAs we have. Okay, you can just read through it. There are like more types of LSAs, like trying to show us like what different kinds of networks have different kinds of LSA packets which will tell you about different networks. Okay, but I think for this video this is more than enough to know the 5 LSAs. Okay, LSA 1, LSA 2, 3, 4 and 5, and you should know what an ABR is. ABR is an interface between two different areas, area 1 and area 0, and always remember area 0 is a backbone area, and every single area should be connected to the backbone area. All the packets should be routed via the backbone area. Okay, that's why, because in order to prevent loops, in order to reduce the amount of traffic updates which you will have to be sending if you make a direct connection, let's say from area 2 to area 1 and area 0 also, then there is a possibility that you will receive an update from via area 0 as well as directly from area 2, which can cause loops, and this would also result in multiple updates which can increase your routing table, right? So in order to avoid these two things, we generally have the backbone area where everything has to be routed via the backbone area. Okay, I hope that makes sense. Okay, it's so generally this, as a network engineer, it's your duty to configure or group contiguous networks and routers into a particular area. Okay, all the routers in the same area have the same topology table, and they don't know about the routers in the other areas. Okay, so this is one of the main reasons why we have areas, and how we configure area is you have an area ID. Area 0 is a must if you're configuring areas, okay, which is the backbone, and everything has to be connected to this. And now let's quickly see, like, how the Dijkstra's algorithm will work, right? Let's say, let me just quickly erase this. Let's say I have multiple paths to reach a particular destination, okay? And as we have discussed before, uh, the cost of each link will be used to determine over here, okay? Now let's say I have R1, R2 and R3, okay? R1, R2, R3. I have PC1 over here, I have PC2 over here. I want to be able to communicate between PC1 and PC2, okay? Now let's say the cost of R1 is 1, the cost of this is 10, the cost of this is 1, this is also 1, and this is also 1, okay? Now PC1 knows that, in order to reach our PC2, it has two particular ways, one via R1, R3, R2, one via R1, R2 and PC2. But it knows that the total cost to reach PC2 via R1, R2 is 1 plus 10 plus 1, which is 12. And the total cost to reach via R3 is 1 plus 1 plus 1 plus 1, which is 4. Okay, so it will choose this particular path because that has the lowest cost link, okay? And this cost basically depends on the size or the bandwidth of the link, okay? Like 10 gig will have a certain cost, 1 gig will have lower, more cost, higher cost, 100 gig will have much lower cost, okay? So like this, based on different costs, it is able to calculate the total amount of, the least amount of cost required to reach a particular destination, and that's how the best path is chosen. It's very similar to how you use maps today, where you have a certain algorithm running, which is basically a Dijkstra's algorithm only, which calculates the lowest cost to reach a particular destination. And that's how Google Maps like shows you, like, this is the fastest way to reach your destination, okay? And also, like, if you are covering a bigger area, then you have to do more computational processing. That's why we have areas. So within that area it will show you which is the shortest path, and then from that area to the other area it will show you another shortest path, okay? So that's how it reduces the computational cost also for the router to process, okay? At the end of the router is also like a PC which has memory and CPU cycles and everything running on it, right? So this is how Dijkstra's algorithm works, and then this will basically install the best path in the routing table, okay? So every router in that particular area will have the same link state database, which will show like which will have the same topological view of the entire area, okay? So this is how OSPF, which is one of the routing protocols, basically works, okay? There are different states, the different types of LSAs which are used to request for updates, okay? And then there is a concept of this area border router, where we have two areas which are separated, and a particular router which is part of both the areas is called as area border router, and a particular router which is part of two different autonomous systems is called as ASBR, autonomous system boundary router, okay? So I'll share a link with you guys, please go through it. This was more than sufficient to like get an idea of OSPF, but if you want to go more into detail, then there are like lots of things which you can, like, focus on. I hope I was able to give you a good concise summary on OSPF. Please do let me know if you have any questions. Please like, share and subscribe. Thank you.